Hello everyone, welcome to my channel. In this video series, I'm going to show you the basics of GPIO programming in Raspberry Pi using Python. At this time, I won't be using remote GPIO and will be doing the programming on the Raspberry Pi, which has the GPIO connections on itself. Later on in other videos, I'll try to show you the remote GPIO feature. For your information, I'll be generally following the instructions on the gpiozero website. You can see the link above, so I recommend you to take a look at this documentation as well. Now we have to connect our Raspberry Pi either via a keyboard or via an SSH connection if it's already connected to your local network. I'll be using SSH connection using PuTTY. Okay, now let's enter the IP address of our Raspberry Pi. Mine is 192.168.1.24. And I'm clicking on open. And now let's enter the username. It's Pi, the password. And now we're connected. Now I'm going to change my directory to the examples directory. I'm going to change directory to Python examples, and I'm going to change directory to GPIO. Now I've already prepared the first file. It's led1.py. Let's see it. As you can see, first we are importing LED from GPIO0, and we are also importing sleep from time. In this line, we are defining to which GPIO port our LED is connected to. Now, you can see that it's connected to GPIO 17. Now, let's see where this 17 corresponds. This is the GPIO pin layout for the Raspberry Pis. On the right, you can see a bigger representation of it. In our code, we had defined our LED connected to GPIO 17. You can see that the GPIO 17 is the 6th pin from top left. And we are going to be using one of the grounds on the board. Here is the 3rd pin from top right. So this is going to be our circuit. As you can see, we have the GPIO 17 connected to our breadboard right here. And here we have a 330 ohm resistor. And over that 330 ohm resistor, we have our LED. Just to mention that we have the anode at this side and we have the cathode at this side. And later on, we are going to connect the ground to the ground on the Raspberry Pi. Now, let's run our script. And as you can see on the script, we are expecting to see the LED to be on and then sleep for 1 second and then off and then sleep for 1 second as well. And since it's in a while true loop, this is an infinite loop, it's going to continue forever. Let's run the script by writing Python 3 led1.py and let's see how it goes. As you can see, our LED started blinking on and off. And by pressing Ctrl Z, we are going to be getting out of the program. Now we are going to run a second script. Actually, this is going to perform the same action on the LED. However, it's written in a different way. So let's see. Let's write vi led2.py. Here you can see that we are again importing LED from GPIO0 and we are importing pause from signal. We are again defining the LED at GPIO 17 and we are saying it to blink with the blink function, and then we are using the pause function from signal. By using the pause function, this is like creating an infinite loop. This is like keeping the script alive, so it's going to keep blinking forever. So let's quit the script and run it with Python 3 led2.py. And again, you can see that our LEDs blinking just like in the previous script. Now we are going to be running another script. It's called PWM LED.py. Let's see the content of it. Okay, now in the first line, you can see that we are importing PWM LED, which stands for Pulse Width Modulation LED. And with this function, we will be able to set the brightness of the LED. Again, we are importing sleep from time, again defining the pin for the PWM LED as 17, and we are creating an infinite loop. First, the LED's value is going to be 0, so it's going to be off, and then it's going to sleep for 1 second. It's going to be half bright in the second term. It's going to be 0.5 as the LED value, and it's going to sleep for 1 second again. Then it's going to be set to full brightness with the LED value is equal to 1, and then it's going to sleep 1 second as well, and it's going to run this forever since we are in an infinite loop. By the way, I would like to mention that this value we have here is called the duty cycle. So if you look, search for PWM and look at its properties, you can see the meaning of the duty cycle. So let's run our script. Let's quit from this one and let's write Python 3 PWM LED.py and run it. You can see that we are having brightness at 2 levels, 0, 0.5, 1, and 0 again. Half bright, full bright, and then 0. So let's stop the script right now and change it. The VI editor. Let's add a line here and set, for example, LED.value is equal to 0.75, and again sleep for 1 second, and that's it. Let's write the file, quit, and let's run it once again. Now you can see that we have 3 levels, 0, 0.5, 0.75, and 1. 1, 2, 3, and 0. I'm not sure if you can see the brightness very clearly. If I make some shade on it, maybe it's going to be better. So we can change the script according to our will, and I'm going to pause it right now. Now we are going to have our last example for the LED. It's named PWM Pulse LED.py. Let's see the content of it. Okay, again, you can see that we are importing PWM LED from GPIO0. We are importing pulse from signal. Again, we are defining the PWM LED at GPIO 17, and we are calling the function pulse. And you will see that this pulse function is going to increase the brightness of the LED, and then it's going to decrease it again. So it's going to continue forever since we are using the pulse function here. So let's see how it works. Let's write Python 3 PWM Pulse LED.py and let's run it. You can see that it's increasing and decreasing in a loop. So this is why the help of the pulse function. So this was the last example for the LEDs. We started to use simple GPIO commands in Python for controlling the GPIO ports on the Raspberry Pi. In the coming videos, we are going to start to use buttons, and we are going to use buttons to control LEDs and to control some other stuff as well. So thank you for watching. See you next time. Bye.